Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey guys, let's go over version B of the Chapter 3 test taken on October 5th, 2022. Multiple choice. Determine if following is a valid statistical question. A statistical question is yes, there is data that varies. What's the batting average of the starter leadoff hitter on the Yankees? What is the batting average of all the players? Well, you're going to get a bunch of different numbers. Then no, it's not a statistical question if you just get one number. It doesn't vary one number or an answer. And what I mean by that is like, what year did Savannah open? The answer is 1961. It's just one answer. It's not going to say 1957. It's not going to be 1982. It's just one answer. How long can students at Savannah High School hold their breath? Well, to me, that means the data is going to vary because it could be 3 seconds or 33 seconds. So this is a valid statistical question. Number 2, the student government at a high school surveys 100 students at the school to get their opinions about the change to the bell schedule. Identify the sample in the following setting. Well, they're asked, all would be the population, all high school students, but they want to know just from the 100 is our sample. This is the sum, and that would be C. D, a sociologist reviews randomly selected surveillance videos from a public park over a period of several years and records the amount of time people spent on their smartphones. The statistical procedure the sociologist used is a census means you give it to everybody, but that's not the case. A sample survey might be, every third person coming by in the park, everybody who's wearing hats, every 5 minutes, I ask everyone there, but that's not happening here. This one is 2 groups. It's an abbreviation, so it's not happening. This one is an observational study. The sociologist is just simply watching the people. Kind of scary. A high school randomly selected 75 of the 200 seniors at the school to take a sample college entrance exam. The mean grade point average, GPA, of the seniors was 2.85 and the standard deviation was 0.4. Select all the statements that are true. Note the margin of error. Let's write down the formula. Margin of error is 2 times standard deviation over n, where S is standard deviation and n is the sample size. Okay, so the standard deviation is 0.4 and my n value is 75. If you put this into your calculator, here's my calculator. 2 times 0.4 gives us 0.08 divided by the square root of 75. This will give us 0.092 is our answer, which is this one, which would be B. Okay. Then it says a couple of options here. So it's not going to be A, because I just found it to be 0.92. Then it says the margin of error would decrease if the sample size would change to 125. That is true. The margin of error would increase if the sample size were changed to 125. So what's the difference? You have increase and decrease. Well, if I go to 125 from 75, this is an increase and looking towards the whole population. So if I go towards the population, the whole, that means the sample is going towards closer to it, so my margin of error would decrease. It would decrease. Why? because you're getting closer to all of the seniors, right? 75 to 125. Then that's getting closer to 200. Now, if I only interview, say, 2 seniors, there's probably going to be a big error or a big difference to what they think about versus the rest of the school. Question number 5 here. Kate conducts a survey at her middle school to determine the student's favorite sport. Which sampling method would best produce a representative sample of the population? They want something that is fair. Kate surveys the football team. Well, the football team is a sport, so already they're going to say the football. This is biased. They're already leaning towards if they like sports or not, so this would not be fair. Kate surveys 7th grade students. Okay. This is okay. Middle school 6, 7, and 8. So she just randomly picks the 7th graders. But my question is, maybe she is a 7th grader and people already know she's doing the survey. And Kate's already on the sports team. So I'm a little bit iffy on that one. I'll wait for that one. C, Kate surveys every 4th student entering the school. I like this one because this one gives everyone a chance. All the 6th and some 8th graders a chance. You see, this one only has just 7th graders, which I rather have. I want to hear from the 6th graders and 8th graders as well. Kate surveys every 8th student from a roster of choir members. Well, the choir members usually 6th period, they're in band, so that is their PE class. So their sport is marching and singing and playing instruments. So it's not going to be their favorite. That would not be. They're already biased. I think they don't like sports. They could, but in general they don't. So I think the best one is going to be C. This gives a fair representation of all, which is 6th, 7th, and 8th. Free response, number 6. Samuel is interested in finding out the favorite social media of other students at her school. Samuel decides she's going to conduct a sample survey to answer this question, explain how she can design her survey, and how she can randomly choose those who will take the survey. We've been using an acronym called DARE. And D stands for digits. Let us use the number of students at the school. So for example, let's just say we have 1,200 students. I'm going to use the digit 1 to 1,200. A is a sign. So I'm going to give each student a number based on their last name. So if your name is Alpha, you'll get number 1. If your name is Beta, you'll get number 2. R is, what do you do with repeats? Well, with this random digit generator, or I can use like slips of paper and just write each of the numbers on there, same size paper. Actually, that would probably be better suited down here when I sign them. Okay, what do you do with repeats? We want to ignore it. So if you're using the random digit generator, you would ignore them. But if you're using slips, don't replace the slips. Just keep it out. So this kind of changes based on what kind of method you're using. Okay. And E means end. You know, I kind of want at least 10% of this 1,200. So 1,200 times 10% is going to be 120. So end when 120 students are selected. Okay? All right, question number 7. In 2020, the Houston Astros were handed down one of the strictest punishments in Major League Baseball for using a camera to steal opposing catcher signs while at their home stadium. It wasn't a good punishment. That could have been worse. What does it basically mean? They were taking the signs. They knew what kind of pitch it was, like a slider, fastball, curveball. And all I can tell you is basically they can relay the message and to know when it's going to be fast or slow. Does that make sense? The signs were then relayed to the hitter by banging a trash can, so the hitter would know what pitch was coming, thus increasing his ability to hit and score more runs. Does the data suggest this is true? Here are the number of runs scored in the 2017 postseason for the Houston Astros for both home and away games. A, find the means for both home. So I'm going to just select the color. Home is going to be this light blue color. So I'm going to say the mean for home, which we're going to find. And then we'll use orange for away. Mean for away. This is how many runs they scored. Okay? So let's go ahead and pop that into Desmos. And what you're going to do is a capital X. Capital X equals. Okay? And then you need to find a bracket. So I'm just going to press the ABC in the bottom left. And it's there in the bottom there. And then we're going to type in our numbers. And you don't need to close your brackets, but when you're done, you're going to see X equals a 9-element list. That's how many numbers are in that list. That's how many games they played. And then you want to go down to the second one. And for right now, you probably haven't memorized all of the functions. So go to functions in the bottom right. And you can scroll through the different statistical ones. And the one we're looking for is the mean. Type in a capital X. And then you have an answer of 5.7 rounded to the nearest tenth. So 5.7, and then away games, they were scoring 3. B, what is the difference? Difference is subtraction. What is the difference in the mean scores of the Astros playing away? So 5.7 minus the 3 gives me 2.7. So that basically means they're scoring at home 5.7 runs and then averaging 3 runs at away games. You might be thinking, well, away, you don't have your fans to cheer you on. You're not used to the park. And so 2.7 runs is quite a bit. Let's figure out how, if it is unusual, 2.7. The dot plot displays the results of 100 simulated 2017 postseasons. So simulated, I want you to think about it, is pretend you put in a video game and then let the computer run itself and then see what the results were. That's what kind of a simulation is. Calculates the means, home games minus away games, and the mean scores that would be expected if there's no differences in performances when they played at home versus away. Based on the simulation above and your answers to question 7b, is it statistically significant that the Astros perform better in home games versus away games? Explain your reasoning. So let's go ahead and locate 2.7. Let's just count. So I think this is going to be 2.2, 2.4, 2.6, 2.8. That would be 3.0, and this would be 3.2. Okay, so we're looking for 2.7s and above. 2.7s and above. So the answer is it? I think it is. Yes, it is statistically significant. And it says explain. Well, I'm going to use the word because. Because 2 out of 100 games is like 2%. And this is smaller than the 5%. So that tells us it didn't happen by chance. Astro cheaters. They didn't even take away their rings. In real life, what does this mean? That home games had the Astros had, I should write that, the Astros had a greater ability to score runs at home, because they had a video system to watch the pitches and relay it really quickly by hitting the trash cans, and one meant fast, two meant slow, or something like that, and so the hitters knew what was coming. I hope that was helpful for you guys. Later.
2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. He that problem board, that problem is easy. Thanks to Mr. Ing.